Hi everyone. Now in 1 week we covered one chapter. So maybe next week before the quiz we have 1 hour. We are going to solve more questions from this chapter, okay? And the last 2 weeks will be about chapter 6. And also you'll have another quiz after this week. Let's see. That's all for this calculus course. So now we are going to use this method, the substitution method we have just learned to solve or to find the area between curves, okay, or this method to find the area for definite integrals. So there are two methods for evaluating definite integrals by substitution. One method is to find an antiderivative using substitution and then evaluate the definite integral by applying the evaluation theorem. And the other method extends the process of substitution to directly to definite integrals by changing the limits of integration. Anyway, actually, the things, I can just have a look. Usually when you just read this kind of things, it may look a little bit unclear, but when you practice one or two questions, you will see that these methods are really easy, relatively easy, I mean, compared to other topics. And we have just learned, right, how to use substitution method. Now, what we are going to add here is we are going to add integration limits, okay? So since when we add integration limits, also it affects the functions in this integral. Now, let's start with this theorem and try to understand this theorem by practicing or solving a few questions. If G prime is continuous on the closed interval AB, and F is continuous on the range of G of X equals U. And I hope you understand why we are using these expressions, because as you see in this our integral, we have G prime of X. To be able to write this here, it must be, what is it? Defined, right? And also it must be differentiable, continuous. Otherwise, we cannot evaluate this integral. And also this F, right? It must be continuous on the range of G, because input value of F is the range of G, right? That's output value of G. So that's just equal to, here we have F of U, and here we have G of A and G of B, right? So what is G of A? Actually, here we have G of A, right? It's just the value of U at X is equal to A, right? And how about this G of B? It is the value of U at X is equal to B. Okay. So that's it, because what is changing here? X is changing, right? And after making it the change, now actually the argument of or input value of F becomes U. So we have to evaluate this integral F on the value of U, right, at A. So the value of U at A is just G of A. All right. So now let me just show some examples to understand this one. Let's start with this example. Okay. See here, X is changing from -1 to 1, right? First, see here, I can make this substitution. Let me introduce this U as X cubed plus 1. Now from here, what is du? Du is equal to 3x squared and dx, right? So now instead of this 3x squared dx, we can write du. And how about the integration, the limits, right? How are they affected by this? So now using this one, so when x is equal to -1, whereas here when x equals -1, what is u? U is equal to -1 cubed plus 1, that's equal to 0. When x is equal to 1, what is u? U is equal to 1 cubed plus 1, it is 2, right? Because in the definition of theorem, we say that they are continuous. That means that since u is a function of x, right, and u is a function of x, when x changes from -1 to 1, and also u assumes on all the values between 0 and 2. And if you remember, that's the first theorem, right, about continuous function, or what is it, intermediate value theorem. So by using this one, now I can change our integral. That's the first part. The second part, the second step. So we can evaluate this an integral. So this -1 to 1, and here we have 3x squared, square root of x cubed plus 1, and dx, and takes this form, everything in terms of u. So u is changing from 0 to 2, right? And square root of, what is x cubed plus 1? That's equal to u. And how about 3x squared and dx? That is du. So now we know how to evaluate this. That's equal to, so u to the power of 3 over 2 over 3 over 2, right? And u is changing from 0 to 2. Well, that's equal to 2 over 3. When u is equal to 2, so here we have 2, and to the power of 3 over 2 minus 0 to the power of 3 over 2, which is equal to, and this 2 to the power of 3 over 2, that is square root of 8, right? So that's equal to 4 square root of 2 over 3. Okay, so that's the value of this definite integral. Usually, actually, this method is much simpler, okay? And also the second method is saying that directly, without actually introducing this x, also you can evaluate this. Also at this point, maybe I'll show you a bit later. Another example. Another example, evaluate the definite integral by using the method of transforming the limits of integration from pi over 4 to pi over 2. Cotangent is cosine over sine, right? A cosecant square root of theta, that is, again, so can we simplify this? Let me just see. Okay, actually, cotangent, cosecant. So that is cosecant. Cotangent, cosecant, that is cosecant. I see. Okay. So I think we are going to use this cotangent of theta and times cosecant square root of theta, right? So I can write it as cotangent of theta times cosecant of theta times cosecant of theta. Also, I think I can simplify. Also, direct I can use here, but how about if I just simplify this as cotangent of theta is cosine of theta over sine of theta times, and cosine square root of theta, that is 1 over cosecant, right? That is sine cotangent, cosine over sine, sine cube. Okay. Sine square root of theta. So that's equal to cosine of theta over sine cube of theta. Okay. The next thing is, how about this thing? Cosine of theta and d theta, right? So that's equal to, what is it? D of sine of theta. All right. So now if I introduce here, let's say u is equal to sine of theta, or without doing this one, it says that by using the method of transforming the limits of integration, right? We have to transform this. So I'm going to introduce this thing. So u is equal to sine of theta. So at the time from here, right, when theta is equal to pi over 4, what is u? U is equal to sine of pi over 4. Sine of pi over 4 is equal to 1 over square root of 2. And how about when theta is equal to pi over 2, right? And u is equal to sine of pi over 2, that's equal to 1. At the time, this integral takes this form. So here we have second step. Okay, integral. When actually theta is equal to pi over 4, our u is 1 over square root of 2. When it is pi over 2, u is equal to 1. And how about this cotangent of theta and everything? We have just changed this into what? Into this sine cube, right? That is u to the power of minus 3. And here we have du, right? Because let's see here, this cosine of theta, right? Cosine of theta d theta, that's equal to d sine of theta. So now we know how to evaluate this. That's equal to u to the power of minus 2, because minus 3 plus 2, right? So over minus 2, from 1 over square root of 2 to 1. Or that is equal to, that's equal to negative 1 over 2, negative 1 over 2. So when it is 1, that's just equal to 1 minus, when it is 1 over square root of 2, right? So here we have square root of 2 to the power of 2, because minus 1 times minus 2 is 2. So that's equal to, here we have it is 2, it is minus, why? It is minus 2 minus 1. So that is 1 over 2 minus half times -1, that's equal to 1 over 2. So then the given integral is equal to 1 over 2. Definite integrals of symmetric functions. Now, actually, this theorem actually is about shortening our procedure to evaluate the definite integral over a symmetric intervals above the origin. So let f be continuous on the symmetric interval. You see here, the symmetric interval is above the y-axis, right, from -a to a. So it says that if f is an even function, then the integral from -a to a f of x is just equal to 2 times integral from 0 to a f of x dx. If you look at graph, right, as see here, it is, what is it? It is when the function is even function, its graph is symmetric about the y-axis. And if it is positive function, so both are areas, right? Instead of evaluating this integral from -a to a, just evaluate from 0 to a and multiply by 2. And the second part is saying that if our function is odd, and if you integrate this from -a to a, and the result is 0. Okay, so that's really the substitution method. That's why it's given here. And sometimes we are going to use this to shorten our calculation process. So let's just prove immediately. Okay, why is it so? Also, we refresh our memory about even and odd functions. Proof A. Okay, so A. So now it says that f is even function. What do we know about this? Even means that f of -a is equal to f of a, right? Even means this, -a or a, it gives us the same value, okay? So now let me just write our integral that I is equal to from -a to a, right? F of x dx. Using the second property, I can just write this from -a to 0. And here we have f of x dx plus from 0 to a and f of x and the dx. Okay. So now the first part, we will see that it's just equal to, again, the same from 0 to a. Now, the first part, okay, I'm going to use substitution method. Let me just label this by I1. So what is I1? I1 is equal to, I can rewrite this as minus integral from 0 to a, right? So minus a, 0 to minus a. So here we have f of x and the dx. Okay, so now if I just use this thing. Suppose that actually u is equal to minus a. Okay, so at the time when actually u is equal, u is equal to minus x. Okay, u is equal to minus x. So when x is equal to 0, what is u? U is equal to 0. When x equals minus a, u is equal to a, right? So using this substitution, then I can rewrite this as minus. So x equals, what is it? When x changes from 0 to minus a, u changes from 0 to a. So f, so what is x? X is equal to f of minus u, right? Because from here, u equals minus x. That means x equals minus u. And so here we have d and the minus u, because x equals minus u. So from here, that's equal to, f is an even function. F of minus u is equal to f of u. And how about the differential of minus u? It is minus du, right? And in form we have minus, so that's equal to from 0 to a. And here we have f of u and du. Or that is just exactly the same thing, because this f of e du, f of x dx, f of y dy, they're all the same thing, right? So that is f of x and dx. And that's why this thing is equal to 2 times integral from 0 to a and f of x and dx. Using the similar method, you can also prove that for odd function, integrating an odd function over a symmetric interval above the y-axis results in 0. Evaluate the following integrals. Now, if you look at this, the integration limits, right, from -2 to 2, that is symmetric above the origin, right, above the y-axis. And also, how about our function? Also, this function it is x to the power of 4, x squared. That means that all the powers of x, they are even, right? That's why it's called even function. So it says even using the previous theorem. Then that is exactly equal to 2 times integral from 0 to 2. And here we have x to the power of 4 minus 4x squared plus 6 and dx. And now to evaluate this one, first we have to find its antiderivative, right? X to the power of 4, that is x to the power of 5 over 5, minus 4x squared, it is 4 over 3x cubed, plus and 6, that is 6x, and the integration limits are from 0 to 2. As you see here, every term has x, so when it is 0, it is 0. Right? So we don't have to evaluate at -2 here. And when it is 2, so here we have 2 times, when it is 2, 2 to the power of 5, it is 32 over 5 minus, and 2 cubed, it is again 8, it is 32 over 3 plus and 12. And just simplify and write the answer. Okay. And how about B? See here, this function, right? It is odd function. And also the integration limits from -3 to 3, it is symmetric about the y-axis. So even we don't have to attempt to calculate this, the result is 0 by using the theorem. And see here, that's the power of knowledge and the experience. If you know the theorem, you don't have to go through a long process and just use the knowledge, and the answer is 0. Now let's talk about areas between curves. Okay, area under one curve is just a definite integral. We have already practiced every questions. Now, how about the areas between curves? If f and g are continuous with f and g, two functions are continuous with, what is it? F is greater than or equal to g throughout the closed interval ab. Now look at the graph, for example, here, the blue is the graph of the function f, and this yellow or orange is the graph of the function g, and totally the graph of f is lying above this orange line, right, over this interval AB. Okay, so in this case, our question is, so we are now going to develop a method how to evaluate the region which is bounded by these two curves and the vertical lines x equals a and x equals b, right? So now it says that then the area of the region between the curves y is equal to f of x and y is equal to g of x from a to b is the integral of f minus g from a to b. Okay, so actually, even using a definition, you can prove that even without a definition, right? So if you find, for example, evaluate what is the integral of f over from a to b, right? So this part, it will be minus, and this part will be, anyway, so let's do like this. I mean, I will use, because, okay, let's just use a definition here. If I just use this other methods, it's also fine. It will be, it doesn't give you actually how we are using the definition of this definite integral here. Now to use the definite integral, okay, how do we evaluate this area? To do this one, we need to draw some rectangles to fill this region, right? But with thin rectangles. So you see here we have the first one, the second one, and the third one, blah, blah, blah. Suppose that starting from a, right, equals x sub 0 till b is equal to x sub n, and we actually constructed n integrals, right? So now let's see here, just if we pick only one of them, this pink shaded region, right, that is kth rectangle, right? And what is the height of this rectangle? The height of the rectangle will be, it is something like this, right? It's height, and this part is, that is f of c sub k. And how about this bottom part? That is g of c sub k. And what is the height? This height is equal to f of c sub k minus g of c sub k, right? So that's why here we are having this function. And after that, this dx means that it is the width, right? That's our delta x. That's our delta x. So that's our delta x. And this integral means so just summing up all of these rectangles. Okay. All of these rectangles. Intuitively, you should understand like this. One example related to this, find the area of the region enclosed by the parabola y is equal to 2 minus x squared, and the line y equals minus x. And of course, to solve this kind of questions, algebraic laws you can solve maybe, but you need to sketch the region so that it gives you, you can visualize what's going on here, what actually you're trying to find here. So now, suppose that this is our coordinate system, and this 2 minus x squared, right? When x equals 0, that's equal to 2. That's the maximum value of this function. So here we have, okay. So that is the graph of this function. Okay. That is y is equal to 2 minus x squared. Okay. And how about y is equal to minus x? Y is equal to minus x. It will be this line, right? It will be this line. Okay. So now they are intersecting each other at two different points, here and here, right? And let's say this point is A and this point is B. And the question is saying to find the area of the region enclosed by the parabola and the limit. So they're asking actually about this region. Okay. So now to find this one, to use the previous theorem, right? First, we have to find the x coordinate of A. What is this value? Let's say this A, and also x coordinate of B. Let's say it is B, right? And how do you find this? They are just the intersection of these two curves, right? So we have to solve this equation to find the x coordinates of the intersection point. So this 2 minus x squared, the first step, that's equal to minus x. Now, if you solve this for x, right, move everything to the right hand side, x squared minus x minus 2, that's equal to 0. And factorize this, it is x minus 2, x plus 1, that's equal to 0. So which implies that then a should be equal to negative 1 and b should be equal to 2. So at this points, right, the x coordinates of the intersection points of these two curves are negative 1 and 2. So to find the region, let me just label this region by S. So this S will be equal to definite integral from negative 1 to 2. Above this region, we have F, right? So here we have F of x minus g of x dx, which is equal to negative 1 to, what is f of x? F of x is 2 minus x squared minus, and how about g of x? That's equal to minus x. Because if you do not sketch this one, you cannot know which one is how, the f minus g or g minus x. You may get wrong answer here. So that's equal to, now if you simplify this here, plus x, right? So here we have minus 1 to 2 minus x squared plus x plus 2. All right. So here we have dx. dx. Okay, so the first one is minus x cubed over 3 plus x, antiderivative of x is x squared over 2. And how about 2? It is 2x. And integration limits from negative 1 to 2. So when it is 2, so here we have minus 8 over 3 plus 4 over 2, it is 2. 2 times 2, it is 4. Minus, what is negative 1? Negative 1 cubed over 3, that is 1 over 3 plus 1 over 2 and minus 2. Okay, so we can simplify this as, here we have 6, right? 6 minus minus 2, it is 8. And minus 8 over 3, minus 8 over 3, minus 1 over 3, minus 9 over 3, minus 3. So minus 3 here, and the minus half. So that's equal to 5. That is equal to 9 over 2, or 4.5. So the area of the shaded region is 4.5 units squared. Okay, one more example. Find the area of the region in the first quadrant that is bounded above by y equals square root of x and below by the x-axis and the line y equals x minus 2. Okay, solution. Find the area of the region in the first quadrant. So everything is in the first quadrant. So that's our x-axis and the y-axis and first quadrant. And that is bounded above by y equals square root of x and below by the x-axis and the line y equals x minus 2. So first, let me just draw our, this one is square root of x, right? And how about x minus 2? When x equals 2, that's equal to 0. When x equals 2, let's say, here we have it is 2, that's equal to 0. And we know there's a straight line. It will be something like this. Okay. So they meet each other. So where do they meet each other? To find that actually their intersection point, again, we have to solve this equation. X minus 2 is equal to square root of x. But just guess and trial as here, if x is equal to 4, right, they intersect each other. 4 minus 2, it is 2, square root of 4. So actually here, this point is, it is 4. The question is, we have to find this actually, what is it, area. Okay. So now I cannot find this area directly. Okay, as see here, we cannot do this one. But how about if I just find like this? So this actually, let's say this area, right? And this is a triangle, the triangle. What is the height? The height is when x equals 4, that's equal to 2, right? So then from the area, let me just write here. Let me just write this S, right? So this S is equal to, what is this thing? The integral from 0 to 4 and square root of x. And here we have dx, right? So it gives us the area of everything here. And minus, I need to remove this unshaded part. What is that unshaded part? It's the area of the rectangle triangle, right? That's equal to 1 over 2 times base is equal to 2 and height is equal to 2. And also in different way, you can find this one, but here, this one is the simplest way. That's why I want to use this method. So that is equal to square root of x. So that is x to the power of 3 over 2 over 3 over 2 from 0 to 4 minus, and this value is equal to 2. So that's equal to 2 over 3. And when x equals 4, here we have 4 to the power of 3 over 2 minus 0 minus 2. And 4 squared, square root of 4 it is 2, 2 cubed it is 8, right? 8 times 2 it is 16. So here we have 16 over 3 minus 2, or that's equal to 10 over 3. So the area of the shaded region is equal to 10 over 3. The last thing I think here, do we have anything else? 1, 6, and 7. Okay, we have 2 examples left, and I want to finish the class today. Now, integration with respect to y. How do we integrate? Sometimes integration with respect to y will see that easier than integrating with respect to x. To do this one, we are just going to use the same idea, but instead of drawing vertical rectangles, we need to draw horizontal rectangles. Okay. Suppose that we are given a function that is given in terms of y. X is equal to f of y. Okay. So we have to differentiate this from c to d. See here, c to d. And to do this one again, we are just dividing this into some rectangular pieces, right? Or drawing rectangles inside this region. And now if you just pick one of them, right? If you just pick one of them here, it is bounded by 2 functions. On the left, it is by this function. On the right, it is by this function, right? On the left, let's say here on the horizontal line, if you're given 2 points, let's say this one is g of y1, and this one is, let's say, f of y1, right? And what is the distance between them? That's equal to the distance. The distance is equal to f of y1 minus g of y1, right? And so here that is the length of this rectangle. And now we have to multiply this by width. So this one is f of y minus 1 and g of y minus 1. And how about this one? That is our delta y, right? And just summing up through this what is the interval? Right, from C to D, it gives us the area of this region. Example, find the area between the curves x equals y squared and x equals y plus 6. Okay. So one way is you can immediately change x to y, and also this x to y is fine. But here, just to practice purpose, okay, I'm not going to change this and do it in this way. Because now if I change x instead of x, y, and y equals x squared, and y is equal to x, right, it will be quite similar thing. But anyway, so suppose that actually here is our coordinate system. This is x-axis and it is y-axis. And what is x equals y squared, right? If it is x and this one is y, and x equals y squared means that now x actually serves as our y, right? And this one is y squared, so its graph will be something like this, right? Okay, it must be parabola. It must be really smooth here. Okay, it's a kind of parabola here. Continuous. And how about x equals y plus 6, right? To draw their graph, if y is equal to 0, or let's say when x equals 0, when y is equal to minus 6. Suppose that minus 6 is here, right? So minus 6, as see here, it is, what is it? When x equals 6, y is equal to 0, it was 6. Okay, so this will be something like this. Okay, right? So now we are looking for the area which is enclosed by these two curves. We are looking for this area. Okay. Now to do this one first, again, we need to find their intersection points, right? At where they intersect each other. Let's say this point is C and this point is D, right? We are doing everything with respect to Y. To do this one, so we have to solve this equation. Y squared is equal to y plus 6, right? Or that is y squared minus y minus 6 is equal to 0. Or if you factorize this, we have y minus 3 and y plus 2 is equal to 0. So when y is equal to negative 2 and y is equal to 3, they intersect each other. So the value of c here, it is minus 2. And value of d here, it is 3, right? So now on the right, we have this function that is y plus 6, right? This one is y plus 6. And on the left, we have this function that is y squared, right? Then the second one, so this area, let's say area is S. So this S becomes integral. Y is changing from negative 2 to 3, right? On the right, we have, what is it? Y plus 6 is x, right? And x equals. So that is, here we have y plus 6 minus, on the left we have this curve, that is y squared. And here we have dy. All right. So which is equal to y squared over 2 plus 6y minus y cubed over 3. And the integration limits, that is from negative 2 to 3, right? So when it is 3 squared is 9. So here we have 9 over 2 plus 6 times 3, it is 18. And 3, right? That's equal to minus 9. Minus, when it's negative 2, 4 over 2, it is 2. Minus 12. And minus, it is 8, right? It is plus 8 over 3. Okay. So which is equal to, here we have 9 over 2. Let me just simplify this. 9 over 2 plus 9. And the minus 14, it is plus 14 minus 8 over 3. That's equal to, here we have 23. And how about this fraction part? The fraction part is, it is 6. It is 27 minus 16. So that is 11. So that's 11. So the answer is 11, and the 23 and 11 over 6. We have another question, and I'll show this later. Okay, that's all for today. Keep practicing. If you have any questions, we'll practice more questions next week, 1 hour. It will be problem solving. Okay, I'm not going to teach anything new. And next session, we will have quiz only from chapter 4. There will be 6 questions. I have already told you. Okay, 3 from optimization problems and 3 from different parts of this chapter. And thank you very much. Have a nice weekend. Okay, see you next week. Thank you. Bye-bye.
Bye, sir.
Bye-bye. Thank you. Bye-bye.